Hey folks, welcome to my channel Number Pen. So there we have the problem on the screen. Integrate the following with respect to x. We have 1 divided by 9x square minus 4. So what we've been given is dy by dx and we've been asked to find y. My y is nothing but integral of the given expression. So let's write down what our y is. That's my y. I know that my y is not in a very simple format whose antiderivative I know directly from first principles. But then when I look at the denominator, I have a 9x square and a 4, right? So a 9x square is nothing but a 3x the whole square and a 4 is nothing but a 2 square, right? So let us rewrite it that way and see if we can resolve this using partial fractions, right? So my 9x square is nothing but a 3x the whole square and my 4 is nothing but a 2 square, right? So now when I take a closer look at the expression what I have, it looks like, I'll be able to resolve this using partial fractions, right? Now, before that, I'm going to make a simple substitution. And the substitution that we're going to do is t equals 3x, right? And you will understand shortly why am I doing this. When my t equals 3x, my dt equals 3 dx, and my dx equals dt by 3, right? Now I'm going to go back to my y and put back everything in the form of t, and you will see that we will have a lot more simpler expression than what we have right now. I will have dx equals dt by 3, so I pull out that 1 by 3 what I have, and then my dx now becomes dt, and then my 3x the whole square is nothing but a t square, and then I have a 2 square also in the denominator, so I have a t square minus 2 square, right? So take a look at this. Resolving this using partial fractions is quite simple. So the way I can do this is 1 by 3 times my t square minus 2 square in the denominator is nothing but a t minus 2 into t plus 2, right? So I'm going to use that particular formula in algebra to resolve this using partial fractions, right? So the first part is a dt by t minus 2, or let me call it a dt by t plus 2. And my second part is a dt by t minus 2, right? So when you take a closer look at this, my first part is a dt by t plus 2, and my second part is a minus of dt by t minus 2, right? And when I do the cross multiplication, I notice that my t gets cancelled in the numerator, but then my numerator will still have a minus of 4, right? So I'll have to compensate for that, which means I'll have to multiply this by a minus of 1 by 4, right? Which means I have a 1 by 3 times minus 1 by 4 outside of the integral, which becomes a minus 1 by 12 times integral of dt by t plus 2 minus dt by t minus 2, right? Now, from here on, it is not very difficult, and if you are still struggling with how to go about solving this, I request you to take a look at some of my previous videos, and I'll put a link to those videos in the description. And at the same time, you should also understand when you know integral of f of x dx equals g of x, how do I go about solving integral of f of ax plus b, right? That becomes equal to 1 by a times g of ax plus b, right? And I'll also put a link to one of the examples we solved around using this particular identity, right? So this one is not very difficult, and the answer to this problem is I will be using some rule of integral to break this down further, because I know that integral of a minus b is nothing but integral of a minus integral of b, right? So I'm going to rewrite this as integral of dt by t plus 2, right? And then minus of integral of dt by t minus 2, right? I hope you folks are with me. So there we are. Now, this is not very difficult for us because we know that integral of dt by t plus 2 is nothing but a ln of mod of t plus 2, and then integral of dt by t minus 2 is nothing but a ln of mod of t minus 2, right? And what we are left with is minus 1 by 12 outside of the integral, so please do not forget that. So I will have a minus 1 by 12 times a ln of mod of t plus 2 is my part 1, and my part 2 is ln of mod of t minus 2, right? So I have my constant here. Now I'm going to do a little bit of rearrangement here, and then again use one of the logarithmic identities that we are quite familiar with. So I'm going to take this minus sign inside, which means my answer to this problem is ln of mod of t minus 2 minus of ln of mod of, sorry, minus of ln of mod of t plus 2, right? And we have this divided by 12, right? Plus c, right? Now I know that I cannot leave my answer in terms of t, and I go back to the original substitution what we did, and we have t equals 3x, right? Let me just highlight it using a different color, say yellow, and then go back and then replace my t with 3x, right? Now I'm going to use one of the logarithmic identities. I know that ln a minus ln b equals ln of a by b, right? So my final answer to this particular problem is 1 by 12 times ln of, I have mod of 3x minus 2 divided by 3x plus 2, right? And then I have my constant plus c. So I hope you found my content useful. Please do subscribe to my channel and support. Thank you.